Um, in this one, I'm just going to implement a linked list. Uh, Pretty open-ended question, but first I'll rant because I uploaded like three-ish videos and I am exhausted, which got me thinking, like these on-site interviews where you have like 5 interviews in a row is completely unrealistic because it's not like in a day's work, you're going to, well, first, you might actually code that long, but you're probably not going to code for that long any given day, or close to it, because it's a very intensive process. Um, and I just feel like that, it's not very realistic to be that intense. And even if it was, and you coded like 6 to 8 hours a day, not everything you code is going to be a completely new crazy puzzle. Like usually, you plop down a microarchitectural plan and you know what you're gonna do, and there might be some parts and pieces of of the puzzle that's showstoppers or like takes a few extra hours, but in a given work day, if you're going to be coding a lot, I would say a lot of the coding is, perhaps on the easier side. So it's maybe that 80-20 rule where it's like 20% of your coding gives you 80% of the trouble. Whereas I feel like in interviews, it's like, well, all the problems are hard and they're meant to be hard. And it's like, well, I understand that as a stress test, but then it also invites people to over optimize by memorizing interview questions, which, really just, again, makes the whole interview process just like a um just like a whole thing of like, well, you know, I'm going to hire you because I know you studied and over optimized for this interview. Um, yeah, I don't know. Anyway, let's get to linked lists. It's a fairly open-ended problem. So let's just do linked list, and um, I will have a parameter, and I would draw some stuff out. Um, Perhaps like 16. And so like if so with a linked list, okay, what is a linked list? If you are in the hardware sort of um well, actually, if you're in hardware, you're probably smarter than software people. I'm just gonna just be real here. Because most people that know Verilog can code software language, it's not vice versa. Um, And if you take offense to that and you're a software person, if you're a software person, why are you looking at Verilog? Uh, but if you're looking at Verilog and you're a software person, then, by definition, you're probably better than other software people. I don't know. But anyway, a linked list is just basically you have a pointer, and this pointer points to, well, you have an object, and this object is basically, holds, a value and a pointer. And this pointer points to basically the next object in the chain. So basically you could have something where, so if I were to say, um, O1 is like object 1, it'll point to object 2, it'll point to object 3, it'll point to object 4, and so on and so forth. Um, And then so yeah, and then the final element point to basically nothing. Um, so I kind of, if it is an interview question, it's like, well, I kind of want to design a linked list with the variable parameterized entries. Like, how would you go about doing that? And yeah, there's a few things. So in a software linked list, you basically can have things that are disjointed in memory, so they're not in a contiguous array, but then one object can point to another. Yeah, so in the same case here, we might just have things that are disjoint in terms of not memory, because your flops have to be, it's hardware, right? You have an array of flops. That's all you have to work with. So you can't really do much outside of that. But what you can do is have the indices of the um, have the indices be specialized. So for example, like let's say you have um, parameter, let's say width, right? And then your width is um, by default, I don't know, like 8 bits. And then so you have it, you know, like a tag that's kind of coming in. And then a tag might be, for example, in a lookup for a entry of if you have a lookup, sorry, if you're doing like a translation look, sorry, no. If you're doing like a page walk, and then you basically have these sort of like pseudo recursive things where like one page refers to another page, and then that entry refers to like a tertiary page, and so on and so forth. These kind of structures might um, be somewhat useful, perhaps, maybe. And then linked list is going to have an address, which is, I guess, the tag here. And then the linked list is sort of useless without data. Um, so yeah. And then so another property of a linked list is like you don't want to just have an array because, for example, if you know anything about like crypto or blockchain, right? Like one block refers to the next block, right? So if I were to say, well, I want to access index 13, but what is the context of that? What came before and after you, right? Like you might not want to access 13, like you might not know what index you even want to access until you know what the previous index was, right? Um, yeah. So yeah, for that, um, yeah, I guess let's just simplify it for right now. So I might have a memory that's like local param, and I think in the last video I did a whole rant on clog1. So I'm just gonna say more than one. Um, Entries width is gonna be clog2 of entries, and then that's it. And perhaps I will just do as learned the previous video. This is what will yeah. So this is how big my memory is, and then hmm, yeah. So actually, I want this to be the address of the thing. So when I say yeah, so why don't I just do this? It'll be kind of in the perverse reverse. So let's say a tag, right? 8. Then my entries width would be 256 or up to 256, aka the width. So let's just think through this. Let's say the width was 2. 2 left shifted by 2 would be 8, and then you do the -1 thing. Or perhaps you can do this, but let's just keep it simple. If you have a width of 1, which is where the trouble usually is, if you have a width of 1, this would be 2 left shifted by 1, which is 4. Um, and then so what am I trying to do here? So it's the opposite of clog2. Yeah, if you have 8 entries, um, Isn't this actually 1? Yeah. So I have 8 entries, and you left shift by 1, that's times 2, and you left shift by 8 is 2 to the 8 power. So if it's 2 to the 8 power, then you have 256 entries. So 256 minus 1, that would be perfect for this, because then, yeah. Okay, so if this was 1, and then 1 left shifted by 1 would be 2. 2 minus 1 is 1, and then it's like 1, 0. So you have 2 entries, even if the width of this tag is 1, which makes sense, because if it's 0:0, tag could be 0 or 1, and then if it's 0 or 1, then you still need 2 entries. That makes sense? Yeah, so that looks okay. So yeah, if I want to complicate it things a bit more, then I would say, well, each entry also has like some value with some width, and then do that. But for this problem, that's not, because we're not really going to do it with anything with the value of the data. And I think as a fair interviewer, like if you just add a bunch of complexity to the problem for no real reason, it's kind of like, why? Like they could do it if they can get the gist of it. So it's like, I just want to ask the question that's the most simplest, where I can tease out, like 80 or 90% of their skill, and then I will just assume the other 10 to 20%, either they have it, but they don't have enough time to show me, because that 10 to 20% will take like 4 times longer to show, or that 10 to 20% can just be learned on the job. Unfortunately, fortunately, most interviews are like this, and unfortunately, some are not. But fortunately, again, the interviewers that are like just like a-holes, are kind of a blessing in disguise, because it's like they're interviewing you, but you're also interviewing them. Like if they're a-holes, then it's like, well, do you actually want to work with that person for like 16 to 24 months at a time? I say 16 to 24 months, because that's optimal time to switch jobs to maximize your money. But if you want to work longer than that, that's even worse, right? You don't really want to be stuck with like people that you don't like. Anyway, where where was I with this rant? Okay, so the tag will access this memory, right? So the I'm gonna access it like this, and um, the thing is, I also need to know like what what is the next thing that I want to point at. So let's say, for mem0, which is kind of like the head of a linked list, right? And I write this tag in it. So for example, um, you know, entries 0, 1, 2, 3, 4, 5, right? And then let's say I wrote in entry 0 like 1, 1 or something, then I want, if I were to do a linked list walk, then I would go from index 0, and the next thing I would read 11. And then so the next time I have a tag, and I probably need to write enable for the tag, then I would like to write on entry 11 whatever this tag is. And then I'll just say, 0 is always the head. Yeah. And then so I guess part 1 of this problem is just implement a linked list. Part 2 of this problem is walk through the linked list without destroying anything. And then if it's like super advanced, clear the linked list, but I probably don't really want to get into that, because I'm tired, to be honest. That's kind of like the only reason. I'm kind of exhausted. So implement a linked list. So let's do that at least. Okay, so we actually need a right pointer. So and because this tag will address, like, it is an address that's in the this tag is an index to the memory, and this width can address all, like, this the memory size is based off of the tag cardinality. So then the right pointer is completely valid just to mirror the tag, because then they both can just access the memory. So if, okay, then we say this right pointer is 0, and else begin. What is the right pointer? So if the right is enabled, then certainly I want my right pointer now to jump to this tag. Yeah, and then so the reason why I don't want to go through like every single one is because there's so many features you could do with a linked list that it's like, is this a software interview kind of thing? So yeah, so right pointer is 0 because we want head to be initialized to 0. And then so yeah, if right pointer is tag, and then so if right enable, then the tag will, in the next cycle, the right pointer will be updated to the thing. And also I want the memory of the current right pointer to basically point to the next thing. Then this means that this actually needs to be a two-dimensional array. So for example, entry 0 will now have 11, and then the right pointer will be 11 in the next one. Okay, and then this way, when you're doing your linked list walk from the head, you'll actually be able to read the data within the memory and then jump around and then kind of make sure things are proper. Okay, so we'll do this differently. I haven't completed the problem, but I kind of want to test each part out at a time because this is 3 distinct parts. So why don't I just, do this with, let's say, I don't know, tag, and then like logic read enable, and yeah, I mean, I guess there's no outputs yet until we get to this part. So we can just probe into internal variables to see the same thing. So what I call this linked list. And then what is this tag and right enable? And then yeah, so let's initialize some stuff. Reset is 1, and tag is our favorite dead beef, and right enable is 0. And then I want to display what? I want to display, I guess tag I don't care about, perhaps right enable I care about, and then some internal states, namely the actual memory. I wonder how two-dimensional arrays are displayed. I don't know. So this might be very long. So I might put that at the end, and then my right pointer, I'll just do a D. Yeah, D is easier for me to digest. D for digestion. I think that's okay for me for now. And write enable is on here, and then the memory is also inside. Right, so I want to give the stimulus first, and then I want to clock it. So the results that I'm looking for, namely this one, and the right pointer update is going to come after the clock. So I can just do our usual thing here. And let's see if it compiles, catch any syntax errors in the way. With W has not been declared yet. My bad. Okay, and then so clock and display, and then I'll just stop the reset, and then I'll just keep write enable as 1 for a while. Actually, yeah, I'll just do it for a cycle just to see how it looks. Actually, this is like way too wide, so why don't we just do like 4? Okay, so it does print out the 6. So it's like now, the other thing is cyclicness, like cycles in linked lists. We're just gonna assume all the tags are unique. So yeah, that makes it easier. And so let's say like tag is 9, and then tag is how, so this could go up to like 15, so 3, and then perhaps tag is so what we have here, we have 6 and then 0. So this is 4 bits, which means each of these is kind of convenient because it's in hex. So each one of these represent one entry of the memory. And then so 2, 3, 4, 5, 6 is 9, and then on the 9th one we have 3, and then the 3rd one we have F. So this is actually working out to be quite good. Yeah, so next is, you know, what if we Now I need to implement a read function. Which will be over a few cycles. And then this will just so this is like a design part, right? So how do you know you've reached the end of your linked list, right? Is it a zero value? Like right now it's X, right? So it could be anything. You could say, well, at the you could say, well, I want to restrict my tags to be, some values between, intervals A and B, and anything outside this A and B is not. And then what you do is you would actually, maybe you would actually set it to 0, and then if the tags are guaranteed non-zero, anytime you hit a 0, that's kind of your signal that it's the end of the thing, right? Another way to do it is you might have an extra bit here, for example, in your memory, and then you would just say, well, in your reset, you're going to do a for loop where, for each entry, you're just going to do 0. So the MSB means not valid, right? So now instead of writing just a tag, you actually need to write a valid bid to it. But then, this is going to be 5 bits instead, and it'll be a little harder to read. Output logic walk, and then output logic end. Terminate. Terminate meaning I'll just say last one. Yeah, so basically I'll just keep walking it if they do a read list. I'll traverse the linked list, and then I'm just going to give a valid entry. Like if it's 11, I'll say valid entry, and then when I walk to the end of the list and it's not valid anymore, I'll just say it's not valid. And it'll operate completely separate of this. So this is just like the flops that write to the linked list. And then, yeah. So let me save this. Let me see if this is working, compiling. Yeah, so this is a bit harder to look at. So perhaps I'll do something like this. Well, I don't think that's necessary because when we read it, we'll know if it works. And we already know this first part works. So, yeah. So basically, this top bit's the valid, and then the actual addressing is written into the pointer. Yeah. So we know this works because we tested it. So now, if we want to read the list, we're just gonna yeah. And what do we want here? So if I am at 0, then I actually want my current pointer also. To have that. So this is read logic basically, or read or like walk logic. And then you could do something like um, um, yeah, this might need to be a status bit. Uh, so basically, this is the valid bit. So if I detect a not valid bit, then I'm kind of done walking anyway. And if I'm done walking anyway, then yeah, like, and then so you can request one at the same time as uh, this thing, but I'm just gonna not. I'm just gonna say clearing takes precedence, and then you like once I clear it, then you can once I clear it, then you can go ahead and request another one, but not while I'm doing it. Okay. Doesn't matter the order in Verilog at all where you assign it, but it just makes it a little bit easier to read, right? Um, and so mm, hmm. So I'll just have this be a slower interface because linked lists are slow anyway. Uh, so instead of reusing the valid entry in this part, I'll actually say that because this valid entry qualifies a walk, and if we don't have this read enable status, we shouldn't be a valid entry um, anyway. So yeah. Um, da, 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 da. Just gonna copy this a little easier. Okay. So the minute I set it, so if this linked list isn't empty, then and the current pointer is 0, it should always be um, a 1. So actually, sorry, I clear it when it's 0. So yeah. And it's valid if the read enable is 1 and this is also 1. So here I'm just saying that if I do this request, I'll do this read enable. Sorry, if I do this request, I'll set this as 1. If it isn't empty, this is also 1. So this is 1. This is 1. Next cycle, this is a 1. If this is a 1, then the next cycle, we also want the walk to have the current pointers thing, and then also the current pointer needs to I want to exclude the valid bit, so actually like this. And then the current pointer is just gonna be the yeah, it's the same. And if I get to the point where, let's say, you know, I am in the tail end of it, right? And the next, I stumble upon something that's a 0 here, or sorry, a 0 valid, and it is like gibberish data, then I would still clock this. Yeah, I would still clock the gibberish data. I'm wondering if the read enable would be out of sync here. One sec. So gibberish data, like gibberish data would set this to 0. And so next cycle, this read enable is also 0. And this gibberish data next cycle would go to walk. So this walk having gibberish data would coincide with read enable being 0. So I'm okay with that. Okay, so there is a couple more interfaces to do, which is these guys. Okay, so these are both outputs. And this is an input, so I need. Okay, so we finished writing this 19315, but perhaps you want to write like 0, just to, oh no, zeros are head, actually. Yeah, that would cause a cycle. 17, oh sorry, yeah, 14, and then we might do like, like 2, and then we might do, have we hit 6 yet? No. And then we do, I thought we hit 6. What? Yeah. 6, 9, 3, 15, 14, 2, 7. We haven't hit. So now I'm like, all right, don't write anything, but start reading. And I'm curious. So I wrote 1, 2, 3, 4, 5, 6, 7 things in there. So maybe I just get the first like 3 just to see if we have anything. Oh, and I want to probably print something out. The memory is kind of useless now because I have no idea what it is. So let's just do walk. Let's just walk. Let's make this a 0 to see if it works. Very good. So let's and then let's also do like valid entry. This last one's deemed not valid. So it had the opposite problem of so write enable is 1 and tag was 7. So I mean this should be written properly. So I'm wondering if this this read enable is 0. So if the read enable is 0, why is it 0? I need the current pointer and read enable. Yeah, this is kind of more like work than I feel like this is like too much for an interview. Um, way too much. Okay. I'm just going to see what the hell's going on with that entry. So write enables 1, and so when we clock and display, we clock it first and then display. So we right pointer is 0 first and foremost, and then I go to 6, and I go to 9, and then. Oh, that makes sense. So this is saying the 0th has 6, the 6 has 9, the 9th has 3, 3, 13, and then the second entry has data 7, pointing to 7, but then there's nothing appended to 7. So actually, yeah, this is correct. There's kind of nothing wrong here. I was just confused. So 2 is linking to 7, but yeah. I'm just saying, yeah, the next one's 7, but 7 has nothing, so it returns nothing. So if I want to do like, yeah, but 7 really has like nothing. So if I wanted to include this last one, because theoretically, I say, well, go to 7, you know, but 7's like null because there's no data there. So do you say like this is the end, or is the latter one the end? You know, if you want to say that the latter one's the end, then you probably need to do something a little bit more special with this status bit here, where even if if the val bit's 0, you say, well, I just delay the well, yeah, you can just delay the val entry by a cycle. Yeah. So yeah. I guess in my case, I'll just call it as is because the video is definitely long enough, and I won't go through how to clear a linked list. Clearing a linked list would just be more work. Like you would have to add a head pointer basically, and you can think of this right pointer, where the hell is it? As your tail pointer, and your head pointer is just gonna walk. It's just gonna do the same walk as this walk, except you're just gonna go through every entry and then clear its valid bit, like so. And then set the valid bit to 0 until you reach a point where um, the MSB of your head pointer is no longer valid, and then now you have an empty queue. So it's just got kind of like a discombobulated FIFO. But anyway, I'll just call this done and hope that they don't ask this question. But this question is fairly open-ended as well. So it's more like if I ask this is more exploratory thing. Anyway, this is super long. See you in the next one. Bye.